Today we will cover the topic of advanced power electronics, and the topic is DC chopper, that is DC to DC converter. So here basically DC chopper means input supply is DC and output is also DC, but output is controlled DC. So that operating principle first of all. So let us come to the contents. Here we will see the operation of DC to DC converter, operating principle, operation. Then different types of chopper circuits, that is buck converter, boost converter, buck boost converter, switchboard power supply like this, bridge converter. All these points we will cover under this. Let us come to the block diagram and definition. So what exactly definition is? That is conversion of unregulated DC input to a controlled DC output with a desired voltage level. So that is a very typical definition of DC to DC converter. So similarly, the same definition we can represent in terms of block diagram. That is, input is DC, unregulated DC, and output is controlled DC. And load may be motor load or something like this. And depending upon the feedback, you may have automation operation, closed loop operation. Now, coming to the application part. As we know that applications are related to battery operated vehicles, switchboard power supply, then DC motor control, battery chargers like this. Okay. So, battery operated vehicle is one of the very good example that here we are using battery as a DC supply, right? And in between that DC converter is there, and at the output side DC motor is connected. So likewise we can go for this application. Similarly, we may go for different types of power supply. As we know that linear regulated power supply is also there, switchboard power supply is also there. So for linear regulated power supply, we know that we are using a power semiconductor device, especially transistor, which will act as an active device, means transistor will operate in active region in case of linear regulated power supply. So here the same figure will show you regarding the transistor operation. So now here transistor is in active mode, then output voltage we can have by the same figure by applying KVL. You may have output voltage VO is equal to V minus VC like this. Okay. So this is the basic operating principle of linear regulator. Similarly, you may go for the switching regulator also. So in switching regulator, transistor will act in as a switch. That means it will operate in saturation and cutoff region. So it is mentioned here like this. When it is in saturation region, transistor will be on. When it is in cutoff region, transistor will be off like this. So the same operation is mentioned here by showing as a transistor as a switch and thereby the operation. So because of that, you may have this type of output waveform, that is on off like this. And you may have duty cycle. What is duty cycle? That is T on off by T on by total T. Total T means T on plus T off like this. And that is nothing but duty cycle. Okay. So you may have, and V is the level of voltage. So for step down converter, you may have output voltage VO is equal to T on by T into V like this. That is D into V like this. Okay. So you may have designing of this equations also. Let us come to the buck converter or step down converter circuit part. Okay, this is one of the important application of DC to DC chopper. So we may design this type of circuit. Here basically inductor is used as a storing element. So inductor will store energy and release the energy. This operation is there. So for storing the energy when switch is on, at that time the energy will be stored by the inductor. Whereas when switch is off, at that time the energy will be released by the inductor like this. So these two operations are shown here. Now coming to next part, that is output voltage is equal to diode voltage minus, that is VM is equal to low voltage is equal to VD minus VO when switch is on. So that condition it is shown here. And here the VL, that means low inductor voltage, is nothing but L DIL by dt like this, and you may find out this. Okay, so it is shown here. Similarly, for off operation of switch, you may have output voltage, that is VL is equal to minus VO. Okay, so here we can then after we can have the analysis part also, and we may go for different things. So let us think about this part, that is